Hey calculates. So, would like to be able to figure out some points on the graph by approximating them, of course. And if we use the notion of a tangent line, I could approximate, let's say, this value right here by calculating what it is here. Let's change the color. What it is right here on the linear graph. Because certainly finding values on lines is a lot easier than finding values on any type of curve. Okay, so to start with the notation, they'll sometimes call them t of x, or you'll see it written as L of x. Both of those are tangent line approximations. And I have to remember that if I'm finding an approximation around this point x equals c by using the tangent line at c, well, the first thing I would know is the slope would be represented as f prime at c. And in addition to that, I'd really be using the point c, because we said x equals c, and of course his corresponding y value, which would be f of c. In other words, the y value when x is c. So if I were to write the equation of the tangent line, then I would have y minus f of c, there's my y value, and then I'd have the slope, but the slope would be f prime of c, and then x minus, remember the x value over here, c. Crazy that that probably should make sense to you right now. And so, of course, getting y by itself would give me, so I'd have to add this to the other side. So I'd have f prime of c times x minus c plus f of c. And then I could call this either t of x or L of x, because that's the equation of my tangent line at some point c. So we're going to look at this in terms of definition of our limit and our derivative. So keep in mind that when we were finding f prime of x, it was equal to the limit as x approaches, or rather h approaches 0, of our slope formula, which was take the y values and subtract them, and take the x values and subtract them, and of course the bottom ends up simplifying and just giving us h. So imagine that these 2 points on the curve are not really all that far apart from each other. In other words, h is really small. So I would be moving this second point up here closer and closer to my first point, making h practically nothing. So now, if I use the tangent line, I can approximate these values. And of course, with the diagram that I have, if I approximate this current y value, I would get this, because I'd use the tangent line and I'd know the equation of the tangent line, so I could simply substitute in x plus h, whatever that x value happens to be, and I would get this point right here. Now of course it's a little bit off, but as I move this point back closer and closer, the distance that it's off would not be so great. So let's say I was estimating here, I'd get this dot on the line, and I go, oh, the distance is not off that much. So we want to try and estimate if we know a point that's fairly close to the one that we're estimating.